And somebody said geomagnetism. So these are all things. Before understanding this, we need to understand Earth and its structure, internal structure. Okay, isn't it? But how do we know that? Earth internal structure means, what is the diameter of the radius of the Earth? I am very happy when this type of students are there. 6,000? This is radius? Okay. Because I don't need to remember figures. Okay. This much deep, how do we study it then? Because what is inside the Earth? We are here. Okay. We need to understand what is there inside. How do we know? You know everything now. You can please tell me one by one. Wonderful. Volcanic eruptions. Okay. Next. Huh? Wonderful. Next. Okay. Excavation, shall I say? Deep hole drilling. Do you know where it is? No. Kola Peninsula. Where is Kola Peninsula? Deep bore. For exploring Earth, scientists, some consortium of scientists have drilled a deep hole, Kola Peninsula. Kola Peninsula is in Russia. Easternmost Russia. Okay. Everybody, I don't know whether you are bringing this atlas or not. Please, every day, whenever we are interacting, please bring this atlas. Okay. As and when we'll go to the map, as and when we are discussing, we will spend some time on each map so that we will have familiarity. Okay, anything more? Excavations? ఇక్కడ చూడండి ఇంకా ఏమన్నా వస్తాయేమో గుర్తు. Your geomagnetism. Because what is geomagnetism? The magnetic behavior exerted by the Earth. That means something inside it making it feel behave it as magnet. So geomagnetism. One more thing you people told. One gravity. Yeah, gravity. How gravity will tell you? How many of you IITs, NITs, or Narayana Chaitanya? No one. Okay. What is the formula for the gravity? Force? Force by? Okay. Basics are important. What is the gravity? Attraction between two bodies. The gravity is nothing but a force. Okay, it is proportional to their masses, but inversely proportional to their distance. The more distance, the less, isn't it? That is the basic funda. That means I don't know here is equal to 1. This is the G is called quality, capital G is small. No, nothing. The gravitational force is proportional to the mass. Okay. Now we all know Earth gravitation force, how much it is? Yes, okay. But by volume also you know, density also we know. So mass it should give us. But is it uniformly spread? May not be. With that volume, with the density, okay. We know the mass also, let us assume. But if density is, let us assume 3 grams per meter cube, okay, or sorry, centimeter cube. 3 grams per centimeter cubed is coming. Let us assume. Is Earth totally is having this much? Our crust, the density is around maybe 2.5. But with this calculation, with the known mass and volume, for us it is coming around 5.5 grams per centimeter cube, the density of the Earth. But we know on Earth crust is that only 2.5. Then what is the thing inside containing? It will give us a different. Everything cannot give you the complete picture. Each one will give you the small picture. Okay, now one by one we will see how volcanic eruption will give us the knowledge of the earth. What materials?
Lava which contains silicon.
Okay. Lava. Then what is the magma here? Somebody told magma.
Magma is from lava inside.
Good. So whatever coming out is called lava. Inside is magma. Okay. It is going to give us the complete information about the earth. That is whatever the known information. So not only lava. Inside the volcano, some sort of material is there, earth internal material, which even magma also cannot melt it. Sorry? Core? Core, you are telling internal structure. I am telling when volcanic eruption is happening, some materials will come out. Everything, if you see the volcanoes, lava, pyroclastic material. The rocks which you are seeing it are, see, inside the earth there is a magma chamber. When it is coming out on the way to the earth surface, the whatever material is there, it is blasting everything. That is only rock material you will see outside. Otherwise everything is melted in the magma. Majority of the things are melted, only few things are the not melted. Those things are on the way, not inside the earth. They are above the earth only, means on the way to the top. But there are certain materials even magma cannot melt it. Can you name anything? The material is called genoliths. Now we will skip. Whenever this word comes, we will skip. We don't read genoliths because it is very tough. Arey yaar, our diamonds here. Diamond. You might have read the most hardest material. That is nothing but a genolith. How diamonds are formed? You can excavate it. Sometimes they will come out also. You know the place called Manikarnika? Manikarnika, yeah. Not movie. You know Manikarnika, who is in our mythology? By the way, I am not at all Hindu religious or anything. Just whatever I know, because I am born and brought up as a Hindu, I am telling this thing. No way bias. Okay. Manikarnika is goddess Parvati. Manikarnika place is near Kulu. You must visit one day. Very beautiful place. Our mythological history is that when Shiva and Parvati are walking on that river, Manikarnika river, she lost her diamond ring. So that river keep on spewing out diamonds. In reality, that place genoliths are coming. On the river beds, you will get the diamonds. Genoliths, because that is the geologically very intense area. You know, there is a langar. Langar, you know. In Sikh, this one, food where it is made, cook. That means what? Kitchen. That langar food is cooked in the geysers. Your rice and your chana and everything are just tied in the cloth and will be kept down in that geyser. They will be boiled. Very beautiful place. So there, these diamonds will come out. Genoliths. Inside the earth, we will start discussing plutonic rock forms. Then we will see genoliths also. Okay. Those will give the more idea than your magma. Because we will see magma is coming from mantle only, not core. But some rocks which might be there will give us the history of what is the mantle exactly, what type of material is there, because of the genolith. Now earthquakes. How earthquakes will give you the information about that? In fact, they are destructive.
There are certain waves which reach till certain.
Okay. No, you say word. What is the word? Waves.
Certain waves.
Waves. What is called? Those all are called? Wow. See, you know each and everything, yeah. Seismic waves? See, more. P and S waves? Any more waves? Wow, see, you are able to say everything. Okay, now shadow zone area. What is that shadow zone area? Why it is a shadow zone area? Refraction.
Like the waves bend and they cannot transfer.
Why? Why?
And the seismic waves cannot pass through that area.
No. No, you are right, but not exactly all the seismic wave. What are these P and S waves? Only P and S waves, anything?
Body waves.
These only longitudinal transfers. P wave is a longitudinal, S wave is a transverse wave. Anything? You said body waves. What, these all are or any other things are? Okay. Anything more? Wow. Arey yaar, you know each and everything. Even geographical optional guy won't be differentiating body waves, surface waves. You are telling. What all are those? Surface waves. These all are body waves. Why? Inside the earth, if earthquake is happening here, if inside the earth, if they are traveling, they are body waves. If surface, they are traveling, they are surface waves. Just simple. Inside the earth means they are P and S waves. Then surface waves, what all are those? Rayleigh waves? Yes. And somebody told? Yeah. Okay, surface waves. But for us to understand the internal structure of the earth, which waves may be helpful? Surface waves? Yeah. Why? Because surface waves are not at all traveling inside the earth. They are traveling outside. Those all are the P and S waves. The only differentiating which makes this understand is that we all know P waves can travel both liquids, solids. S waves cannot travel. Okay. We will discuss more about the seismic waves when the earthquakes we are discussing down the line. Okay. Now, excavation, geomagnetism. Geomagnetism also, when I am discussing continental drift theories, you used the word, right? Then we will discuss. Okay. So these all are the things we will be using it. With the help of these things, we whatever humans know earth history, earth internal structure is because of these things. Okay. Now we will see what is the internal structure of earth. I think you all know. You will tell me. Yeah, please. Yeah. Crust, mantle, core. Any more words you heard? Inner core, outer core. Any more words? Okay. First, crust. Okay. Next. Next. Somebody said inner core, outer core. We will write. Inner core. Okay. Somebody said word. One more word. Any more word? See, crust, it is a oceanic crust. Internal structure. Huh? Yes. Okay. Above, below. Okay. I will write first. Okay. One more word. Whoever is telling this asthenosphere, mesosphere, I want one more word from them. Yeah. Okay. Now, these all words you are hearing. What is the difference? If you see, crust is 0 to 30 kilometers, lithosphere is 0 to 100 kilometers, gone. Very confusion, isn't it? Generally, the internal structure of the earth is differentiated. The various names are given based on the chemical composition or the mechanical behavior of the parts. So, I will say the two ways you can discuss the earth structure is, internal structure is chemically or mechanically. Both together also we need to discuss. That we will see. Now, let us assume this is a pie. Out of earth, you know, this is the earth, okay? I am just taking this. The topmost is the crust, okay? What is the width of the crust? 0 to 100 centimeters, no. Roughly, Kani, if let us assume this is a continent, this is the ocean, okay? Continents have more thicker crust, oceans have more thinner crust, okay? This is around 5 kilometers, 0 to 5 kilometers, this is around 0 to 30 kilometers crust, okay? I am, for the sake of roughness, I am taking 30 because it is more deeper. Next is the mantle. Out of all layers, mantle is the beautiful layer because of which everything is happening on earth. And by volume also, it occupies almost 60 to 70% of the earth volume, mantle. Mantle is the one we are going to spend much of our time, okay? It is around 2,900 kilometers. Next is a outer core, inner core, okay? Now, anything more you want to tell me about this outer core, inner core? Okay. Outer core is in the form of liquid. Okay. Inner core? Why it cannot be liquid?
Due to high pressure and temperature.
Due to?
High pressure.
But here also high pressure and this one?
But as the mantle is not
you know highest temperature where it is there? Here. Here.
the reason is pressure is dominating over
Yeah.
temperature.
It's a simple physics law. When you increase the pressure, the melting point will increase. It is such a right amount of pressure and temperature, it will remain in the solid. But remaining here, it is liquid. Here, the constituents are nickel and ferrous. Here, majorly ferrous. And it is in liquid form. Because of it is in liquid form and constituents are nickel and ferrous, earth is getting its magnetism. Because the liquid core here, liquid outer core is in convectional currents motion. If it is the earth, it keep on moving, okay? These movements will be changing also, directions will be changing, but it is a convectional current. Because of your convectional current, you are getting the geomagnetism. Simple, our electricity principle is there. A material which is in motion, our cycle, Chinnapur cycle, Atlas cycle, if it is there, if you see dynamo is there, what is that? Nothing but that only, energy is being coming. Here, iron is in continuously motion, fluid motion. That's why you are getting the magnetism. And this direction sometimes changes also. If it is a counterclockwise, sometimes it is counterclockwise and it is convectional. That's why earth geomagnetism also reverses. If today earth north pole, okay, is south pole, magnetic north pole is this, magnetic south pole is this. But maybe after some million years, it may not be the same. Here magnetic south will be there, here magnetic north will be there. That is reversal. It is also very much important for us to understand what is happening in earth. Radiometric dating, coal, what did you use the word? Coal? Carbon dating. Okay. That carbon dating, radiometric dating, like this also. This is also one, because by understanding the earth geomagnetic polarities, you will understand which period it might be, because it is a known history. Okay. Mantle again divided into upper mantle and lower mantle. This is around 700 kilometers. Let us take it. Okay. Now I told what is the average density of the earth, 5.5, no, don't remember, just for the sake of 5.5 grams per centimeter cube, but crust is only 2.5. It keeps on increasing. Okay. When it keeps on increasing, there will be sudden change in the densities. For example, at this point from crust to mantle, and how did we differentiate this mantle, core? At least mantle, here liquid is there. Here again solid is there. Why can't we have 1, 2, 3, 4, 5 names? Why crust came on mantle? Because in that region the material behavior, composition is same. The what is the composition? Majorly. Yeah, you are right. Okay. Okay, next. Okay. Knifey. Already I wrote. Okay. This is the chemical composition. What is Cl? Cl means the materials, the rocks, the constituents are containing majorly silicon and aluminum. You know, earth crust, the major first element is oxygen. Around 40% of the earth crust is with the oxygen. I am not saying atmosphere. Earth crust, this is. Okay. Whereas next is silicon, aluminum. They are very light color. The density is less. They are lighter, but they are rigid also. Next, Sima. The more deeper you go, the more darker it is. Not only because of the organic matter. Organic matter will be like whatever, when you are digging, you might be coming across darker material when you are going. That is not because you cannot dig 30 kilometers beyond 30 kilometers. Even like few meters only you might have seen. If we cross this crust area inside this, the material is changing to magnesium. Silica is there, but major constituent it became magnesium. The density is also going to around 3 to 3.5. Okay, outside I am writing. So, whenever your seismic waves, whatever is there, you are reading it, the speed is changing. P wave can travel solid as well as liquid, but in the solids also it will show difference of speeds based on the constituents material. At this point, suddenly there is a change of material. So, one scientist understood this. Yes, there is a change of material. He called it, it is not a continuity. There is a discontinuity. That is called Mohorvik discontinuity. Okay, or Moho. It is a scientist name. Where is this Moho discontinuity? Between crust and mantle. Why? There is a sudden change in the constituent of the material. The densities are changing. The behavior of the material is changing. That is, and similarly, one more discontinuity was found from here mantle to liquid. Here around 3 to 3.5 grams per centigrade density is there. Suddenly it will go to 7 to 8, or here it will go to 13 also. 7 to here 10 around. How much difference is there? Very drastically it change. And basically, forget about the density. It is a solid, it is liquid. You will easily understand that. So, that there is also one discontinuity. That is called, yes please. Gutenberg discontinuity. Okay. Similarly, from liquid outer core to solid inner core. Does anybody know? Layman is not exactly that. That is called Bullen. But don't worry, because here we don't differ. See, for us, for geological understanding, the interest part is mantle only, not this. Okay? Mohawk, Gutenberg discontinuity, that is why they were called discontinuous, but the constituent material had changed. Core is Sial, it is a lighter, silicon and aluminium. Mantle is Sema, this is Niphy. Total it is called Niphy, but in the solid inner core mostly ferrous is there, iron. Nickel is a bit less, but in the outer liquid core nickel and ferrous. And your geomagnetism is coming because of which layer? Outer. Outer what? Outer core, because of convectional currents there. It is in the liquid part. So why currents are there? Can't it keep idle? It has to keep on, because there is a radioactive decay. Radioactive decay means earth is having radioactive material. One material will be having one sort of radioactivity, one material, inside that, let us assume here one sort of radioactive material is there, here one sort of is there. They have decayed. Decayed means they destructed or changed from isotopes. What happens? They give out the energy. When they give out the energy, obviously the heat and density will change. Even though everything is liquid, the density parts will change because heat is changing. When there are different densities in the same level, what will happen? Flow will happen, isn't it? Higher dense material, lesser dense material will start flowing because of the density difference. Because of the radioactive decay, there are the convectional currents, but it is not exactly that is the only reason. It is one of the reasons. We also till now not known. It is not known that completely because of which it is happening. Because now next I will go. You want me to continue or finish it, or what? You want break? Continue. Okay, we will finish it. Okay. Now here I told upper mantle and the lower mantle. Why I told? Because now we will see how mechanically they will behave. Okay. Mechanically, this is very rigid, brittle. Brittle means virigipotundi easy. You cannot, malleability will not be there. Sagadiyalem vatni. Whereas in this mantle there is certain layer which is plastic in nature. Plastic means like mana smooth ga, flow ga undi. It's not like solid. Like our rocks, if you see on the earth, isn't it rigid? It is a cooler also, lighter also, less dense also. Less dense. Sial is very less dense. Whereas inside the mantle there is a certain portion which is plastic in nature, which is a slowly moving one, highly dense, viscous. What is viscosity? Snigdhata. మనం ఇంటర్మీడియట్లో చదువుకొని ఉంటాం. ఓకే. It's not exactly the resistance, flowing liquid, the resistance it exerts is called viscosity. Okay, just I'm telling. Here whatever material is there, more viscous than this one, and plastic also, that is called asthenosphere. That is lying around asthenosphere. Okay, now I am not speaking crust, mantle, core. I am speaking how it is behaving. That's why I asked the definition of the viscosity. Mechanically how it behaves. It is more viscous and it is a bit plastic. On top of it there is a more rigid, lighter, less dense material. That is called here, till here, lithosphere. Don't worry about thickness, that is 100 kilometers, and they will say that inside the oceanic crust it is a 30 kilometers, oceanic crust is less, everything, that all things are there. Just we need to understand the concept. You understood? inside the mantle there is a layer which is more viscous, plastic and moving on, that is asthenosphere. Above it there is a cold, dense, cold, lighter, resid material, resid layer which is called lithosphere. This lithosphere is nothing but crust plus upper mantle. For you to have analogy with your this chemical, this one, this lithosphere is not only crust, it has the mantle part also. Why we are discussing in these terms? Because to understand how the movement, how the mechanical behavior of the internal part of the earth, okay, and remaining everything doesn't matter. They call it barysphere, somebody call it mesosphere. We never, only once introduction we will come to know, no book will discuss anything about that. So don't worry, these two are the most important things for us, because lithosphere is the one on which we are going to study the landforms, different mountains, faults, okay, rifts, or what do you call it, oceanic trenches, continental slopes, ocean deeps. These all things are on the lithosphere. What making it to happen? Why earthquakes are coming? Why volcanoes are coming? Why certain places only mountains are there? And why mountains orientation is north-south, majority of the places are horizontal, not across? What is it? That all things are decided by the movement of lithosphere on this asthenosphere. That's why I told, mantle is the most important thing for us, not anything else. For your economic geography, crust is the most important, because your minerals, your soil and everything, even crust is also not the topmost layer of the crust. But for geomorphology, your mantle is the most important thing. Your even volcanoes are coming, the magma is coming from the mantle only, and climatology is above that. You understood? Oceanography is on the crust only, that's right. Oceanography, just for the sake of understanding the oceans, they make it separate science, because it is a very bigger. For us, it is a bit limited scope is there. Am I clear till now? This is internal structure of the earth. See, if you start reading exhaustively, you will get lot of information. But how much is necessary for us, you need to. That is.